Hey everyone, hope we're doing good. Today we're going to be taking notes on lesson 1-3. So make sure that you have your note packet out because we will be filling this in. So 1-3 is all about midpoint and distance. So we only have two objectives for today. The first objective is to use the midpoint formula to find the midpoint of a segment drawn on a coordinate plane. And the second objective is to use the distance formula to draw the length of a segment, or to find, the length of a segment drawn on a coordinate plane. So finding the midpoint, finding the distance. That is our new vocabulary today is midpoint and then distance/length. So we're going to talk about what does that mean. And then we have 3 theorems and postulates we're going to talk about. Pythagorean theorem, we're just going to review really quickly since we haven't seen that in a while. Midpoint formula we're going to talk about, and the distance formula we're going to talk about. So at the end of this packet should be that sheet that has all of the terms on it. And so we're going to jump down there and we are going to define midpoint and define distance and length. So here we are at the end of your packet. You should have this page that says terms, topic 1, right? Terms. And we're going to scroll down until we see distance length. So here's that right here. And we're just going to define this really quickly. So the distance or length is the absolute value of the difference of coordinates. So meaning, I'm going to make a little note up here, like if the x coordinate is, let's say 2, and the y coordinate is -1, let's just say, then the distance from x to y, remember difference means subtract. So if you don't remember that, I'll write it in right here. So difference means subtract. Okay, so that means I'm subtracting. So the absolute value, so I'm going to draw my absolute value bars, of 2, because that's my x, minus, and then my y is -1, and then I'm going to close my absolute value. Okay, so this gives me the double negative here turns to plus, so I have 2 plus 1. So this becomes the absolute value of 3, which is just 3 units. So the distance, right, is the length from one endpoint to the others. And I forgot my little segment, right? So the segment XY has a length of 3 units. So hopefully that makes sense, right? It's just how long a line segment is. We are going to talk about angle bisector and perpendicular bisector. I guess we should just do that now. So I'm going to clear this one and talk about angle bisector real quick. So that word bisect, right, when you think about science or something, right, bi means 2, and then sect means to cut. So when we're talking about a bisector, we're cutting something into 2, right, into 2 equal pieces. So if I have an angle, I'm going to draw it a little bit bigger just so that we can see it really clearly. And let's call this angle CAT. If I draw another ray, it goes out like this, and it's a ray, so it has arrows, and I call this B. Okay, if this ray cuts my angle in half perfectly, so if this angle and this angle are the same, and I know that they're the same because I have those tick marks, right? So if they're the same, then that tells me that AB, so ray AB, so because it's a ray, right, we have to draw the arrow, is the angle bisector of angle CAT. Because CAB and BAT are equal. So we can write that too. Angle CAB is congruent to angle BAT. So hopefully you feel good. It just means I'm taking an angle and I'm cutting it in half. Okay, angle bisector. Okay, so let's go ahead and clear this and go down. Two more here. Perpendicular bisector. So perpendicular bisector is a line, segment, or ray that divides a segment into two congruent parts. So if I have a segment, and let's just call this segment AB. Okay. If I have another line that divides AB into two equal parts, let's call this middle point C. Okay. So if AC, line segment AC, is congruent to line segment BC, that's why I have these tick marks here, because they're the same length, right? They're exactly the same length. So that's great. That's the bisector part, right? I've split line A or segment AB into two equal parts. Now the perpendicular part also tells me that this line has to be perpendicular. Okay, so this line has to cross at 90 degrees. So not only is AC congruent to BC, but, and let's call this line L maybe. Okay, so also line L is perpendicular. Do you guys remember the symbol for perpendicular? It's an upside down capital T. Oops, that's not what I wanted to write. So is perpendicular to line segment AB. So this line L is perpendicular to AB because it crosses at 90 degrees. And A to C is the same length as B to C. So that's what we mean by perpendicular bisector. Okay, and then last one is midpoint. So it's the point that divides the segment into two congruent pieces. So if I have a segment, let's say A and B, and I have a point in the middle, let's call it M. If A to M and B to M is the same, then M is the midpoint. M is the midpoint of AB, right? It's the middle if A to M, oh, please fit, is congruent to B to M. So as long as this length, A to M, is the same as this length, B to M, then M is the midpoint. So those are the quick definitions for this unit. So not as many as last lesson for sure. But we are still going to talk about two formulas, and then we're going to review Pythagorean's theorem as well. So if you keep scrolling down, if you turn to the next page, which is all about postulates, formulas, and theorems, we're going to be looking at our different formulas and then also our reviewing Pythagorean's theorem. Okay, so I'll let you get to that page quickly, and then we'll talk about this. So hopefully we're there. If not, just pause the video. Okay, so we're going to talk about the midpoint formula first. So if I want to find the coordinate of the midpoint, I want to know what is the midpoint. Okay, this is the formula that I'm using. So the midpoint means I take the two x coordinates of my endpoint, add them together, divide by 2, and then the two y coordinates of my endpoints, add them together, divide by 2. So I'm going to do a quick drawing of what I mean by this. So here's a line, let's just say, okay? So if this point is x1 comma y1, let's just say, and this point is x2 comma y2, then this is my midpoint, right? Is that cool? So midpoint, so sometimes I call it xm comma ym, and that m should be down below. Let me see if I can make that better so we're not writing them next to each other. Okay, so x, and then it should be a subscript, a little tiny guy down here at the bottom. M, there we go. And then y, m. That's better. So that's what this is right here. So I just add the x1 and x2 and divide by 2, and that gets me this. And then I add my y1 and my y2, and I divide by 2, and that gives me this. So hopefully we're feeling good there. And that's just how we find the the midpoint of that. Okay. If I want to find the distance, so what is the length of the whole line? I'm going to use this formula right here. Notice it still has the x2s and x1s and y2s and y1s. It's the same points. So if this is my line, right, this can still be my x1, y1. This can still be my x2, y2. And then that just tells me that this whole thing right here is the distance, is the length. So how long is this line? Well, I take my two x's and I subtract them, and I take the square, and then I square them. And then I take my two y's and I subtract them and I square them, add them together, take the square root. So hopefully we're feeling pretty good about that. Even if we start one example or do one example, I think that we'll pick that up pretty fast, hopefully. The last one is that I just want to review really quickly is Pythagorean's theorem. It's used to find the third side of a right triangle. So make sure that it is a right triangle, meaning it has a 90-degree angle. So the Pythagorean's theorem is a squared plus b squared equals c squared. And what's really, really, really important about this, and I'm going to try very, very, very hard to make sure that I draw this accurately, okay? So there's a right triangle, right? Because it has a 90-degree angle. You want to make sure that C is always the hypotenuse. I don't care where A and B is, but C always has to be the one across from the 90 degrees. C is always the hypotenuse. So that's just probably the most important thing on this is making sure that whatever value is across from the right angle, that is the value that's going in for C. A and B are interchangeable, so you can choose, right, which number goes in for A, which number goes in for B, but C always has to be the hypotenuse. So that's actually it for all of our terms and our definitions and theorems and stuff for this lesson. So all we have now is to actually do the lesson. And so what we're going to do is go back into our packet to that 1-3 starting point, and we'll take our notes. So I'll see you guys in a second. Okay, so we're back here at 1-3, midpoint and distance. And we're going to start just at the very beginning, right, with example 1. And we're going to go over how do you find the midpoint of line segment A to B. So again, to review, the midpoint, the x-coordinate of the midpoint is your x1 plus x2 over 2. And then the y-coordinate is your y1 plus y2 over 2. Okay, and so this is all we're going to do to find the midpoint. So let's start with the x-coordinate. So here, it doesn't matter which one is x1 and which one is x2. Those just tell you that it's the first point or the second point. So if this is x1, y1, then this is x2, y2, or you can switch them, it doesn't matter, and call this the 2's and call this the 1's. So let's go ahead and solve for the x-coordinate first. I'm going to take my x1, which is -3, and I'm going to add my x2, which is 4. And that's all over 2. So if I keep going, -3 plus 4 is 1. So I get 1/2. So I'm just actually going to leave it as 1/2. Now I'm going to do the same thing for my y's. Okay, I'm going to take my y1, which is 2. And I'm going to add my y2, which is -2. So 2 plus -2. All over 2. Well, 2 plus -2 is 0. And 0 divided by 2, we should know, is just 0. So my midpoint, the x-coordinate of my midpoint is 1/2. And the y-coordinate of my midpoint is 0. And that's it. We're done. That is the midpoint of this line. That means if I were to graph the line, the point 1/2, 0, which is right here, that is the midpoint. That is the middle of the graph. So you have 2 try-its here. So I want you to just go ahead and try finding the midpoint with these two, with both A and B, using this formula right here, right, the midpoint formula. So go ahead and hit pause here, and if you need like a little jump start or something like that, go ahead and hit play. But once you've done A and B, go ahead and hit play on the video to check your work. Okay, so here's my midpoint formula again, and I'm going to go ahead and do this with points C and D. Okay, so the x-coordinate here, so I can say the x-coordinate of the midpoint is x1. So my first x is -2, plus x2, so my second x is 8, all over 2. -2 plus 8 is 6. So I get 3. Okay, now if I want to find the y-coordinate of this, I take my first y, which is 5, and I add my second y, which is -12, all over 2. 5 plus -12 is -7 over 2. I don't know why I wrote a 3. So sorry. There we go, over 2. And -7 divided by 2 is -3.5. So the midpoint of this line segment is 3, -3.5. And that's it. So hopefully this is making sense a little bit. We have one more to try here. So to find the x-coordinate of line EF, we take our first x, which is 2.5, and we add our second x, which is -6.2, divide by 2. So 2.5 plus -6.2 is -3.7 over 2. And if I divide that, I get -1.85. And it's okay to get decimals, okay? Then the y-coordinate, so ym, is my first y, which is -7, plus my second y, which is negative 3.8, all over 2. So when I add those together, I get negative 10.8 over 2. And if I divide that in my calculator, I get negative 5.4. So this tells me that the midpoint of line EF has an x-coordinate of negative 1.85 and a y-coordinate of negative 5.4. And there we go. And I forgot to box them, right? We should always get in the habit of boxing our answers. So pardon me for not doing that in part A. There we go. Hopefully we feel good about this. If not, go back, watch the videos, try another one. You do get some practice on this in your assignment today, so that'll be good. Or just reach out to myself or a teacher to get some additional help on this one. Okay, example 2 here is all about, finding a partition of a segment. So what we mean here is for example, it says, what is the coordinate of the point 3/5 of the way from A to B? So I'm not trying to find the coordinate of the midpoint, right? I'm trying to find the coordinate 3/5 of the way. So like in here or in here, right? Somewhere else along the line. So because it says from A to B, that means that we start at A. And so that's really important. If it wanted from B to A, you would start at B. But because it's from A to B, we start at B. And so what we have to do, and I'm going to just kind of write this out in steps. So step 1 is that we need to find the horizontal distance. My pen is starting to get jumpy on us. So find the horizontal distance. Okay, so that's the first thing we want to do. So in this case, my horizontal distance from A to B, horizontal, remember, is left to right. So this is a 3, and I go from 3 to 13. So if this is 3 and this is 13, what is that distance, right? And hopefully we say that that distance is 10. So in this case, my horizontal distance is 10. Okay, so this is what we do once we find the horizontal distance. I take my fraction, which is 3/5, and I multiply it by my distance, which is 10. Okay. So I have a fraction times an integer or a whole number, so I want to make this a fraction as well, so I can multiply straight across. So if I put that over 1, that'll make it a fraction, and now I can multiply straight across. So 3 times 10 is 30, 5 times 1 is 5, and 30 over 5 is 6. That means that you are going to add 6 to your x coordinate. You're going to add 6 to your x coordinate. And I'll explain what that means here in a second, okay? So I'm going to get rid of this now. So you add 6 to your x coordinate, okay? So now step 2, and of course I don't really have room to write it, but we'll try. Step 2 is to do the same thing, but find the vertical distance. So vertical distance so in this case, my vertical distance, right? Let's look. This coordinate is -4. This coordinate is 11. So the distance, remember, it's the absolute value. So the distance here is actually 15, right? Because I go -4 to get to the x-axis, and then another 11 to get to point B. So it's 4 plus 11, so the total distance is 15. So then I'm going to do the same thing. I'm going to take my fraction, which in this problem is 3/5, and I'm going to multiply it by 15. And I want that to be a fraction, so again, I'm going to put it over 1. And we can multiply straight across. 3 times 15 is 45. 5 times 1 is 5. And 45 divided by 5 is 9. So this tells me I'm going to add 9 to the y coordinate. Okay, so I'm going to add 9 to the y coordinate. Now we just need to ask ourselves, okay, what coordinate do we start at, right? And because I'm finding from A to B, this is my coordinate that I'm using. So A, I'm going to run out of room. Let's do it down here. A equals, right, 3, -4. And I know now that I'm going to add 6 to my x coordinate, and I'm going to add 9 to my y coordinate. Because I just found that out, right? So I get 3 plus 6 is 9, and -4 plus 9 is 5. So that means at the point 9, 5, so 9, 5, right here, 2, 4, sorry. Yeah. My scale's off. Hold on one second. We're going by 2s. Okay, so 9, 5 is right there. There we go. That is 3/5 of the way to B, is 9, 5. So the coordinate of the point 3/5 of the way from A to B is 9, 5. So basically, if I were to split this line into 5 parts, right, 1, 2, of course. I'm going to try to do it really well. 1/5, 2/5, 3/5, 4/5, 5/5. There we go. Right? This is 1, 2, 3/5 of the way. Okay, so 2 try-its here. I actually give them a shot, right? Find if you can figure out the 0.7 of the way from A to B. So again, you're starting at A, and just your fraction is changing. Instead of 3/5, it's 7/10. And then here, it's 4/5 of the way, so your fraction is changing to 4/5, but it's from B to A, so you're going to start at point B instead. So go ahead and hit pause, give this a try, and when you're ready, hit play. Okay, so let's go ahead and give these a shot. My horizontal distance is still 10, and my vertical distance is still 15, so that hasn't changed because we're looking at the same line. If we're looking at a different line, you'd have to figure out what those are. Okay, so all I'm going to do is I'm going to do it up above so that we can fit it all. I'm going to multiply my fraction, which is 7/10, by the horizontal distance, right, 10 over 1. And I get 70 over 10, which is 7. So that means I'm going to add 7 to my x coordinate. Then I'm going to do the same thing, 7/10, but I'm going to multiply it by my vertical distance, which is 15 over 1. I'm going to cancel here. Is that okay? I get 10.5. Okay. that means I'm going to add 7 to my x-coordinate and add 10.5 to my y-coordinate. So, and because I'm going from A to B, I'm starting with A. So A is equal to, again, 3, negative 4. And I'm going to add 7 to my 3 and 10.5 to my negative 4. So 3 plus 7 is 10. And then negative 4 plus 10.5 is 6.5. So there is my coordinate point. So at 10, and then 2, 4, 6.5 right there. So that's the point we're looking at. Okay, let's change color for this one. Okay, so then for this one, 4/5 of the way from B to A. So again, I'm going to do the same thing, just with a different fraction. So 4/5 times my horizontal distance, which is 10. I get 40 over 5, which is 8. So I'm going to be adding 8 to my x-coordinate. Then I'm going to do the same thing, 4/5 times 15 over 1. And I get 4 times 15 is 60 over 5, which is 12. Barely fit it. So that tells me I'm going to that I'm either adding 8 or adding 12, right? But this is the kicker right here. I'm going from B to A. So because I'm going from B to A, watch what happens, right? My horizontal distance from B to A, this length, is now negative 10 because I go to the left. So that makes this a negative, which makes this a negative, which makes this a negative. That makes sense, right? Because I'm going from B to A. So I'm going the opposite direction. So it's negative. Same thing here. I'm going from B to A. So I'm going down 15. So that makes it a negative 15, which makes this a negative 60, which makes this a negative 12. So instead of adding 8, I'm actually going to end up subtracting 8. And instead of adding 12, I'm going to subtract 12 from my point B. So B is equal to 13, comma 11. And I'm going to subtract 8 from my x-coordinate, and I'm going to subtract 12 from my y-coordinate. So 13 minus 8 is 5. 11 minus 12 is negative 1. So you have to pay attention on where to start, right? So here I'm starting at B. Start at B. So you want to make sure that because I'm starting at B, to get to A, I'm going in negative directions. So I'm subtracting. Again, reach out to a teacher, reach out to myself or a teacher if you need help on this, figuring out how we did it. All you do is find the vertical distance, find the horizontal distance, and multiply it by that, whatever the fraction is that you are given. Okay, and then that'll tell you what to add or what to subtract from your coordinate. We are actually, so I'm going to go ahead and erase this and scroll down. We actually already know this guy, example 3, is just rewriting the distance formula. So what I'm going to do here is, since we already have the distance formula in our notes, right? We just talked about it earlier. We're just going to write the distance formula. So distance is equal to, here's the square root of, so you take x2 minus x1, so your two x's, subtract them, squared. And then your y2 minus y1 squared. So there's your distance formula, and we're going to use this for example 4, which is our last example. So we're just going to practice finding the distance that a pitcher throws a ball to a batter. So what I'm actually going to do is scroll down so we can see this, and then I'll rewrite the distance formula here. So distance equals, make it hopefully nice and neat, x2 minus x1 squared plus y2 minus y1 squared. Okay, so example 4 is all about finding the distance. So it says a pitcher, right here, throws a ball to a batter. Okay, so we're talking about baseball here. So pitcher, throws the ball to the batter, who hits the ball to the shortstop. So the ball goes here, and then it goes here. If the ball travels in a straight line between each, right? So straight line to the batter, straight line to the shortstop. What is the total distance traveled by the ball? So I need to know what the distance is from the pitcher to the batter, and I need to know what the distance is from the batter to the shortstop. So I'm actually going to have to do the distance formula twice. So how we distinguish it is we say, okay, what's the distance from the pitcher, to the batter? Right? So pitcher to the batter. And so in order to be able to plug things into this, I have to know the coordinates. So let's look. The coordinate of the pitcher is 2, 4, 5, and then over here is 2, 4, 5. So this coordinate right here is 5, 5. And then the batter is 0, 0. So now that we know what the coordinates are, we can go ahead and start plugging these into into the equation. So, and again, it doesn't matter what you call x1, x2, y1, y2. So I'm going to call this the 2's, and I'm going to call this the 1's. So my second x is 5. So I'm going to do 5 minus my first x is 0. So I pulled the 2 x's from one from this point and one from this point, and I'm subtracting them. Plus, and then over here, my second y is 5 again, and my first y is 0 again. So there it is. And then now I'm just going to simplify and solve. Root 5 minus 0 is 5. So I get 5 squared. Plus, again, 5 minus 0 is 5. 5 squared. 5 squared is 25. Plus 5 squared is 25. And if I add 25 and 25, I get the square root of 50. And if I plug this into my calculator, I get about 7.1. And then 7.1 what, right? I don't know the units, so I'm just going to say units. 7.1 units. So travel 7.1 units. Because look, 1 unit is 9 feet, but we'll talk about that later. Okay, so that's the distance from the pitcher to the batter is 7.1 units. Now I want to find the distance from the batter to the shortstop. Well, I know that the coordinate of the batter is 0, 0. So now the shortstop, I have 2, 4, 5 up to 10. So this point is 5, 10. So now I'm going to do the same thing, and I'm going to solve. Okay, so again, I'm going to call this 2. So 5 is my second x, minus 0 is my first x from the batter. And then my second y is 10, so plus 10 minus my first y is 0 squared. 5 minus 0 is 5. 5 squared is 25. Plus 10 minus 0 is 10. And then 10 squared is 100. Right over here, and I get the square root of 125. Which again, if I plug that into my calculator, I get about 11.2 units. So notice that I'm using squigglies here so that it's saying approximately. That's letting me know that I'm rounding it. Okay. So the total distance, sorry, I don't know why I'm writing at an angle, is 7.1 plus 11.2, which is equal to 18.3 units. Okay, however, it wants me to round my answer to the nearest tenth of a foot, meaning I actually need to figure out how many feet this is, and it tells me that 1 unit is 9 feet. So all I have to do now is take my 18.3 units and multiply it by 9 feet. And I actually want to adjust this. 9, let's put in our units so we don't get confused, right? 9 feet. So 18.3 times 9 is 164.7 feet. So the total distance that this ball travels is 164.7 feet, which is pretty far, right? So that's the total distance from the pitcher to the batter and from the batter to the shortstop. Now, if I get rid of this, there is a try it. So looking on your paper, I'm just going to read it because we kind of want to keep this image up, right? So the try it says, how far does the shortstop need to throw the ball to reach first base? Meaning, it's a lot harder for me to draw it at this angle. What is this distance right here? That's what it's saying. What is that distance? And it says round your answer to the nearest tenth of a foot. So you will have to find your answer in feet, not just in units. We already know that this coordinate is 510. And looking here, this coordinate is 10, 0. So using that, find the distance from the shortstop to the first baseman. When you're done, go ahead and hit play, and then we'll go over it. Okay, so hopefully we tried it. Even if you got it wrong, at least you tried it, so good job. That's how we learn, right? Is we try something, we make a mistake, we learn from it, no big deal. So let's look here, and I'm going to use the distance formula. I guess I could have that written already, sorry. The distance formula, x2 minus x1 squared plus y2 minus y1 squared. And so I'm going to do this all up here just because I don't have a whole lot of room down here, okay? But you should be doing your work down here under the try it. So I'm going to start plugging in values. I know 5, 10, and I know 10, 0. I'm just going to call this one 1 and this one 2, okay? It doesn't matter. So x2 in this case is 10 minus x1 is 5 squared plus y2 then would be 0 minus y1 would be 10 squared. So if we keep going, make sure you're always drawing that square root, that radical symbol, okay? 10 minus 5 is 5, so I have 5 squared plus 0 minus 10 is negative 10 squared. Keep going, drawing that square root the whole way. 5 squared is 25. Negative 10 squared is positive 100, right? Negative 10 times negative 10. So I get the square root of 125, which we found earlier was about 11.2 units. However, it says round your answer to the nearest tenth of a foot. So we need this in feet, and we need it to be rounded to 1 decimal place. Again, I know that 1 unit is 9 feet, so I can take 11.2 and multiply it by 9 feet, which gives me about 100.8 feet. So the distance that this ball was thrown from the shortstop to first base was 100.8 feet. And really, like here, if you're getting confused, don't forget you can always write, and you don't have to, but you could also write this as D from shortstop to first or something like that, right? Just to help you stay organized in what you're doing, right? You're going from shortstop to first base. Okay, so hopefully a little helpful go over about finding the midpoint of a line segment and finding the distance of a line segment. Last time I'm going to say it, at least for this video, if you need help, reach out right away. Don't wait. Let's go over it together if you need to. Whatever you need, reach out to myself or your teacher or whatever you need. We are here for you. And I'll see you next time. Bye.